Good morning, everyone, and thank you, Susie, for the invitation to be here this morning and to sort of share my thoughts. I think meetings and fora like these are probably one of the core things right now. And I think I spend a lot of my days actually in meetings, just being with colleagues and talking about stuff and sharing stuff. And I think because we as humans are such a relational species, I think it's critically important for us. Just like during COVID, when we sort of came together and worked through that, I think that's one of the really, really important pieces right now. So let's go ahead and share and let me know if everything is coming through okay. Does that look okay at your end?
Yes.
And it's in
Yes.
presentation mode
Okay.
now.
Now it's in presentation mode.
Okay,
Hmm.
perfect. So we'll keep our fingers crossed that everything goes smoothly here. All right, so starting off with kind of like the big picture and just getting us grounded in some of the things that I know you work in and are really close to your heart. For me, it's always about pictures, right? Because the other thing about us as humans is that we're storytellers. And so for me, um, using remotely sensed images, satellite images, air photos, really tell a story. And so I always start off with a picture. And in this case here, we're looking at the Otter Creek and the way in which we're looking at really dry conditions and how that affects not just the water quality, the water quantity, but also, the deposition into Lake Champlain, but what happens to fields that it's flowing through before it gets to the lake itself. So we're going to talk a little bit about some of these pieces of weather and climate change, and what are some of the things that are coming down the pike, but also looking forward to the future and maybe thinking about how can we be strategic and hopeful and move forward as we step through. So just to get us sort of grounded here, when we're looking at everything that is in that sort of weather, climate change realm. I like to look at it through the lens of the different hazards that we face. So usually people think about flooding and drought, so in the water realm, but also the temperature extremes, so high temperatures, low temperatures, really strong winds, which could also have a desiccating, a drying effect on our standing species. But then the storms themselves. So we've had a particularly snowy winter, and how does that sort of play out in the knowledge that we have as our climate continues to change? Wildland fire smoke, um, air pollution events, but also a lot of the things that are stressors from a biotic perspective. So just to get us grounded in that. So I work really closely with my colleagues at the National Weather Service at the Burlington International Airport. And so one of the slides that they created a couple of years ago in the wake of the flooding that we had in the summer of 2023 was this slide that sort of shows the top weather events that have affected us. And as meteorologists and climatologists, we like to take a long-term view so that we can best place what's happening now, the observations that we see now in that longer perspective. And so some of the events that you see on this slide here include the Great Flood of November 1927, Tropical Storm Irene, the Long Island Express that we had in September of 1938, the flooding from 2 summers ago, but we cannot forget a lot of the wintertime events, including the ice storm of 1998, which was really my first introduction to all of the variability and change here in the state of Vermont. And then going back to the 60s, there was another particularly damaging ice storm back in December of 1969. So, of course, it begs the question, what is it about Vermont? What is it about upstate New York all the way across to Maine that makes us so prone to all of these events? And then how do they affect us in the various socioeconomic sectors, including agriculture? And a lot of the answer has to do with our topography. So, where are our mountains and valleys? How are they oriented? What does that mean for moisture? What does that mean for different types of snowstorms? And so as you're looking at this slide here, the Green Mountains in Vermont, the White Mountains in New Hampshire, of course, all part of the Appalachian Trail. And so that sets up a particular barrier in terms of where a moisture falls or doesn't fall. And it also sets up a barrier in terms of what type of precipitation we observe. So that as you're looking at this event of December a few years ago, there was snow on one side of that storm and icing on the other side. So topography is not trivial because it helps to determine where we get that upslope, and therefore we're getting more precipitation on one side versus the other. And that then plays out in terms of which sectors, like the transportation sector, which are particularly prone to when we have flood events because of where the rivers and the roads are from a socio-cultural perspective in here. So thinking about that and jumping straight into some of the questions that we are really pondering at this particular time. How are we planning for our changing climate? How have we planned for our changing climate? And what are some of the things that we need to kind of keep in mind here? So in the initial Vermont Climate Action Plan, which I was looking at the chat and I see there are a lot of folks who've contributed to that and are continuing to contribute to the Climate Action Plan process at the state level. One of the things that it was my privilege to sort of spearhead was the writing of the what does climate and climate change look like in the state of Vermont. And so this slide here was created by my colleague, Dr. Jason Schaefer, in looking at the various hazards that we see across the state. So you'll see the precipitation, heat, the storms, wet storms, the ones that have a lot of heavy wet snow in them, but things like drought as well. And what in our best estimation, so Jay is a meteorologist, I'm a climatologist, what in our best estimation do we think, based on all of the studies, based on our own research, is going to happen with some of these types of events and hazards? So on the x-axis here, you see the direction of change. So whether they are going to increase, whether they're going to practically stay the same, or whether they're going to tend to increase. So that's in this direction, left and right, along the x-axis. And then on the y-axis in here, we have what do we think is our confidence level. So confidence levels sort of go back to a lot of national climate assessment, the Intergovernmental Panel on Climate Change, IPCC, way of sort of framing a lot of our current knowledge, state-of-the-art knowledge in terms of different types of events. And so towards the lower part of the y-axis here, we've got less confidence because sometimes there are just fewer events so that the sample size is smaller. And so there isn't that much to sort of draw from. But then either events that are very well studied, very well understood, and less variable in nature, we have a higher confidence in how those things are going to change in here. So that was a diagram, like I said, in initial climate action plan, but we're also keeping it in the current version of the rewrite of the plan that's taking place right now. So when we think about all these hazards and we think about honing in on pieces that are critically important to us, sometimes we always think about moisture, so either too much moisture or too little moisture. And when I look at this particular graph here, which is a slide that David Herring at NOAA put together, what we can see is changes in precipitation. So that's this lower diagram here. And as the climate continues to change, as there is more moisture in the atmosphere, that means that there's more moisture to fall out of the atmosphere. And so what you're seeing here on the lower diagram is that there is this move towards heavier precipitation, so more 1 inch, 2 inch, 3 inches of rain falling at given time frames. So sometimes it's over the course of an hour or so, sometimes it's over the course of multiple days. And so that shift towards heavier precipitation that shifts the entire distribution is what we're seeing in here. And then fewer times or fewer days or fewer amounts where we've got like little drizzle types of events, right? So we're seeing that already. The upper part of this diagram shows from a temperature perspective, from a thermal perspective, what are some of these pieces that we're seeing. And so this shift towards higher temperatures, whether it's on a day-to-day basis, a seasonal basis, or an annual basis, and more times when we're breaking the records that have been in place. And when we talk about breaking the records, a lot of our records go back to 1895 or 1880. So we're talking about these 200 years worth of information that we're looking at here. So at the same time, if we are shifting the entire distribution to higher temperatures, that means there are fewer of these lower temperatures. Doesn't mean that they've gone completely, but there are fewer occurrences of them. And so for us as humans, that sort of translates to kind of like muggy nights because the temperature is not dropping as low as it used to be. So, of course, that then plays out to when the precipitation actually falls. With the influence of topography that we just looked at here, we're going to, of course, continue to see those higher amounts in the higher parts, the spine of the greens, into Mount Washington and so forth in here. So the flip side of too much moisture is, of course, too little moisture. So we can look at droughts because droughts are still part of our story, a critical part of our story. And so what this slide here is showing is sort of like a visual example of drought. I had another one from Sam Mazza's stand in Colchester where it was so bone dry. You literally just had to walk on it and, the soil was dispersed into the atmosphere because there's so little moisture in the upper levels of the soil itself. Here's another way of looking at it from a larger perspective where you can see the places where in normal conditions, regular conditions, when the lake is at its regular value for that particular time of the year. So we're talking about the middle of summer here, how far towards the shore it would be. And the sort of distance away from the shore here gives us an idea of how dry the conditions were, at least in that particular drought back in 2016. So this is a diagram from NIDIS, the National Information Drought System. And what it shows us here, again, like I said, a lot of our records go back to 1895. And what we can see is the browns, the oranges, and the yellows are showing you periods when we were in drought conditions, and the teals, the teals and the blues and the greens in here show you when we were in wet conditions. And so if you're familiar with the US Drought Monitor, this is the product that is part of that. And the darker the colors show you the more severe the droughts were. So the darker browns show you the severe droughts that we had in the 1960s, but also earlier in the record itself. And as we look in here, we can see that we still have droughts. We still have to pay attention to droughts because they have not disappeared completely. They're still part of our hydrologic story. But this diagram is really great in showing you that there was a sort of flip in the switch in the early 1970s when we went from being a particularly dry state. I always say if I were giving this talk back in the 1920s or even 1960s, we wouldn't really be talking about flooding. We'd be talking about droughts. So there was a flip around 1970 or so to a more pluvial or wetter time frame where we've gotten wetter over time interspersed with these drought. And you can see again, because they're darker values, these are still particularly severe droughts that are still part of our record. So one way of trying to sort of quantify or visualize this notion of droughts and floods taking place at the same time is to use the hydrograph for Lake Champlain. And so these hydrographs here were generated from data from the gauge that's just outside of the Echo Science Center. So as you're looking at this, all four of these show the same thing, where the upper blue line here is the highest that the lake has ever been. The lowest green line here is the lowest that gauge has ever been. The red line is the median value, the middle value, and then the last one is whatever that year is. So we've got 1909 is that purple line here, 1927, which you see we went from a drought to flood in 2 days. The 60s, I picked one of the middle years to kind of show how dry that entire decade was. So this is an example of that. And then in 2011, we actually set two brand new peaks. So the May floods in here set brand new peaks. And then, of course, Tropical Storm Irene set some peaks in here. So that's one of the reasons why I always say we need to kind of keep our eye on both sides of the hydrologic extremes in here. So this is a map that was released last Thursday. We're working on the one that's going to be released tomorrow. So tomorrow will be the 13th. So again, this is the US Drought Monitor. And some of you probably worked with this because it triggers a lot of FSA assistance and other type of assistance depending on which category we happen to be in. So the state has actually been in drought for the last at least month or so. So we've been in abnormally dry conditions for most of the state, and then the southeastern part of the state into New Hampshire and into southern Maine has been in moderate drought. If you look a little bit further south, you see that we actually have extreme drought in the southern part of the Northeast, which means that we are sort of like some of the drought conditions that we see out in the West. So that's one piece in there. Let's switch for a sec and talk about what else do we think about or that's important when we're looking at our changing climate. And the other thing that we look at is our temperature regime. And the temperature regime across our seasons, because that gives us a better sense of how things are playing out than looking at an annual value. So we're looking at seasons, and it's important to note that the winters are changing the most rapidly of all of our seasons. And last winter, so the winter of 23 into 24, was actually the warmest since 1895 across a lot of the northern sector. So that's these darkest values here, right? You're looking for those brown burnt sienna colors. So you'll see a lot of the state actually recorded that warmest ever or within the top 5. So again, this is some of Jay's work, and he sort of listed out some of those years and what the average value was at the Burlington International Airport. So our changing winters, warming winters, particularly important from an overwintering perspective, and from, of course, things like our maple industry, which depends a lot on the fluctuations that take place during the winter. So here's that slide again, but this time without all of it by county level, so that you can get a sense of which states actually had either the warmest on record, so a rank of 129, or the second warmest on record, which is 128. So if winters are changing the most rapidly, we put a pin in that. What else can we think about or talk about or understand from the other seasons? And one of the other seasons that's critically important is, of course, our spring. So what we have seen, and this is actually something that was seen back in the 1800s as well, this notion of a backward spring, which means instead of the temperatures continuing to warm like they usually would, March, April, May, getting into June and so on, temperatures actually either fluctuate or they go in the opposite direction. And in some cases, you've actually seen either snow or freezing rain, sometimes frost conditions, as far as Mother's Day, right? So back in terms of May. So these are particularly challenging, especially if they occur after, plants have budded, or you see this taking place in January, and everything wakes up, starts to photosynthesize, and then you have different types of injury taking place as a result. So thinking about spring and thinking about all of those changes that we're seeing in spring makes me think back to 2023, 2024, when we had, like last year and the year before, you had frost conditions in the spring, and then you had all these drought conditions in June, and then we had the flooding taking place in July of 2023. And there's a special name for that. Those are what we call compound events, and when they occur one after the other like that, those are called temporally compounding events. And it sets up challenges for messaging. It sets up challenges for how do you deal with some of these when they're taking place either back to back or at the same time? How do you get the message out? How do you work with that? Because frost, droughts, wildfires, and then floods are particularly impactful for agriculture as an economic sector. So here's what it looks like, not just during that episode, but then what happens when the entire produce comes in. So this is an apple that I had gotten. Well, it's 15 years ago now, at the horticultural farm in South Burlington slash Shelburne. And when I saw it, I asked the folks there, what is that? And they said that was a frost that took place in May of that year. So that just sort of allowed me to, again, expand my research and my understanding to sort of to quantify what the impacts are across the year, and then what are the species that are of particular susceptibility. So frost followed by wildfire. So if you're looking at this slide really, really closely, I'll let it play for a sec. What you'll see is, yes, the floods that we had in July of 2023, which is a lot of this, all of these storm systems that you're seeing across the spine of the greens, particularly in the central part. But as you look at that, you're also going to see that that was taking place at the same time. We still had wild and fire smoke coming from the Canadian provinces and the western part of the US as well. So if I freeze that for a sec and jump ahead by 1 week, you'll see that once the flooding rains had moved out of the area, we were still dealing with wild and fire smoke. So again, that notion and understanding of these temporally compounding events and why we need to sort of appreciate how that kind of plays out. So all of this is place-based. And so as we're looking at these various aspects and hazards and changes, what really struck me was I was giving a talk a few years ago, and I think it was out in Fairleigh. And as I was preparing for the talk and always trying to make it as local and place-based as possible whenever I give a talk, I pulled the drought monitor map for Orange County. And this is when it sort of really drove home to me that one part of the county could be above normal or normal in terms of moisture and precipitation. And then the other part of the county could actually be in drought. And so when we're thinking about all these weather, climate, and climate change aspects, they have to be local. And so keeping that in mind, switching to the Intervale in Burlington, because I was giving a talk there last year. And as I was preparing for that one, I was giving a talk at the Intervale Center here, pulled up the Google map for the region to get us a sense of where that was relative to the Winooski and why do we see so much flooding taking place in the Intervale. So I'm just going to sort of flip through, kind of zooming back out, if you will, going higher up into the atmosphere to get a sense of what are some of the upstream effects, what are some of the effects close to where a lot of the community gardens are in the Intervale. And as we move higher up and get that broader perspective, I'll do one more here. What we'll notice is that a lot of the Winooski and its floodplain is really, really expansive. And as we look at the current meanders, we can also see places where the Winooski has flooded in the past. So we're looking at these cutoff meanders here, and we're looking at that particular set of pronounced meandering that this river does as it makes its way out to the mouth just north of the north end in Burlington, and getting a sense for why there tends to be a lot of flooding in the Intervale whenever we have a particularly large flood event. So this is the Intervale here. And these are some slides that were taken during and after Irene itself. So let's get to the money question. What are we doing? What can we do? How much money is this going to take? And what are some of the options? What are some of the alternatives? Let's put all these things on the table here. So one of the things that we can think about that we were moving towards was thinking about climate smart agriculture. And so this is a slide that comes from the 5th National Climate Assessment. And I'm using this to kind of prime the pump because one of the suggestions I'm going to have is to sort of lean into some of this existing body of work to the extent that we can. And how does that sort of give us a leg up in terms of what are some of the possibilities that may still exist? Another thing that I'm just sort of going to put out there, because I don't want it to be lost in the way that we are thinking about things broadly, is a lot of the work that we have been doing in terms of green technologies, sustainable pieces, and just to make sure that that's still part of our conversation to the extent that it can be. And my final slide will show why I still want to have these things front and center. So if you haven't read the Fifth National Climate Assessment, an amazing document that spans everything from all of those um, understandings of complex hazards, but also different regions, so the Northeast region, but also by sector. And so the next suite of slides are just to sort of whet your appetite for going and taking a look at some of the work that's been done in the ag chapter if you haven't already done so, because a lot of these have identified some of the challenges that are near and dear to us because we live it. And so the last sentence on here in terms of opportunities for increasing resilience and protecting rural livelihoods is still critically important. And how do we use some of these vetted resources to actually continue the work that we're doing here on the ground itself? And part of my strategy of showing you some of these is that messaging continues to be important, but we don't have to reinvent the wheel. So please borrow shamelessly with accreditation to NCA 5, any of the pieces that you think might be helpful in terms of whether you're putting together additional resources or working with individual communities and so on. So the ag chapter is chapter 11. And again, if you haven't seen some of these, I'm just going to offer them by way of making sure that they're still in our resource toolkit. So thinking about changes across the food supply chain, and again, very nice way of putting all the various hazards across here on the top, and then breaking it down by the various parts of the supply chain that are important, and then how some of these things could be affected. So that's, again, still in chapter 11. Thinking about examples of where food security comes into our discussion, and whether it's food that is unavailable, inaccessible, unusable. So whenever we have flood events, contaminated waters, again, it sort of brings together all of these various pieces in a way that is both 508 compliant, but also allows you to sort of really visualize this and take it through. Building that resilience in our rural communities. This slide sort of speaks to the different types of baselines that occur, the institutional frameworks, the governance frameworks, the community capital, all of these pieces that are, again, important for us to have as part of our conversation. From an agroecological perspective, I love when they do the gears because it shows that motion of how do we go through the various pieces of what we're trying to look at, and which can actually sort of help us switch and shift between whether it's biophysical, social, and technological pieces in here. And so I'm going to leave this up for a sec just in case anybody wants to whip out their camera and do the QR code. Also happy to send to Susie so that you can, again, find some of this stuff readily if you'd like to take a deeper dive in here. So what are we going to do? How are we going to try and move forward? What are some of the possibilities and opportunities? So I'm going to start off with possibility for partnership with the Vermont State Climate Office. And in a service learning perspective and internship perspective, how can we build that collaboration with my office, with the students in my classes? And here's an example of some work that was done by Dr. John Christie, who's the Alabama state climatologist, and his work really, really closely over multiple decades with the agriculture sector in his state and the ways in which he was able to quantify some of the challenges, but also create indices that speak to what could be used by the agricultural personnel in his state as well. So that's one suggestion, and happy to chat a little bit after about that. Another thing is if you want to work directly with communities, this is an example of one of my classes. I teach a climatology and natural hazards class, and we worked with the town of Underhill to help bring climate change into their local hazard mitigation plan. So my students did that back in the fall of 2022. And again, just bringing together all of the resources, no need to reinvent the wheel here. And one of the things that they wanted us to kind of focus on was what else should they be looking at apart from floods? How can they bring carbon sequestration into the plan and the planning and the process that they were looking at? And so really, really messy because there was no structure, right? And so we had to create the structure so that both the town of Underhill got wonderful results, the students got an amazing real world experience, and using a lot of the existing resources like the climate resilience toolkit, because there's a very set process and how do you step through that. So one of the things that I think is reflective and a thread that kind of runs through everything that I've presented so far is in all of the uncertainty that we are facing right now, we have to be ready to make the case for extension. So you never know when there's going to be that opportunity. You could be in the supermarket, and the person next to you might be at a particular whatever that could bring some resources. So have that elevator speech ready on what is it that's important, why do we care, and if there are dollar signs that could be put to it, how can some of those resources be brought to bear? And as we're thinking about this, networks are critically important, and so are there communities outside of Extension that we could be working with or messaging to? And then this comes out of a lot of my work with state government. I always have that list of shovel-ready things that could be done if resources just suddenly fell into your lap, one-time resources, for example. So this I got yesterday because I was part of a writing process. We're doing a special issue on climate services. And one of the folks at Cooperative Extension at Cornell, David Kay, actually shared this with us. So it's the advocacy toolkit. And if you haven't seen it, I'm happy to share that link with you. It's right in the lower right corner in there. And it's a way of working in the current environment in a way that's multifaceted, but helps to actually move the conversation forward. So with that, thank you so much again for the opportunity to be here, spend some time. I'm going to see what's in the chat as soon as I turn off this part in here. And I am going to leave you with a special plea because of the number of touch points that you have all the way across the state and region. Please, please, please share the word on asking folks if they're already taking weather measurements or rainfall measurements to become part of the CoCoRaHS program, because we need to know where our rain is falling and how much rain is falling, because it just gets the Weather Service even more data to improve their forecasts and improve the way in which we understand how precipitation is taking place across the state. So with that, I'm going to turn it back over to Susie and stop sharing. Thank you.